All right, let's talk about something every single Java developer deals with: exceptions. Now, I know they can feel like a chore, but I want you to start thinking about them differently. Think of exception handling as your developer's superpower. It's the tool that lets you turn a fragile program that crashes into a really robust professional application. Let's see how it's done.
You know the feeling, right? We've all been there. You've written a piece of code, you're sure it's perfect, you hit run, and then, bam, the whole thing just stops. The program crashes, the user has no idea what happened, and you're left staring at the screen. It's that moment of chaos when something you didn't expect just blows up the normal flow. So what's actually happening under the hood?
Well, this is what you get: a cryptic error message that brings everything to a screeching halt. This right here, this is the chaos. In this case, our program tried to do the impossible: divide a number by 0. The Java runtime saw that and said, nope, can't do that, and threw an exception. And because we didn't have a plan to handle it, the program just gave up.
So, to build that plan, here's our roadmap. We're going to start by really understanding the problem. Then, we'll look at the try-catch safety net. After that, we'll talk about guaranteed cleanup with finally. Figure out the difference between errors you can anticipate and ones that are just bugs, and then we'll wrap it all up with the key things you need to remember.
Okay, first things first. What is an exception, really? It's just an event, something that happens that disrupts the normal, happy path of your program. It could be anything: trying to open a file that isn't there, losing a network connection, or that classic dividing by 0. And if you want to write professional-grade software, just ignoring them, well, that's not really an option.
But why should we really bother? What's the big deal? Well, handling exceptions is what separates hobbyist code from the real deal. It's about so much more than just stopping a crash. It's about giving your user a good experience even when things go wrong. It lets you recover gracefully and keeps your main code clean. Separating the what to do from the what to do when things fail. This is how you build apps that are tough, resilient, and just plain work.
All right, so let's meet the hero of our story, the try-catch block. This is your #1 tool for taking back control from chaos. Think of it like a safety net. You put it under the part of your code that you think might be a little risky, and it's there to catch any errors before they can bring down your whole application.
So how does this safety net actually work? It's pretty simple, really. First, you wrap your risky code inside a try block. If something goes wrong in there and an exception is thrown, the try block stops running immediately. Then, the Java runtime system looks around for a catch block that matches that specific type of error. If it finds one, it runs the code inside that catch block. If everything in the try block went perfectly fine, then the catch blocks are just skipped. Easy.
And check this out. Here's our safety net in action. We've put that dangerous division inside the try block. As soon as the arithmetic exception gets thrown, our catch block swoops in and intercepts it. And look, the program doesn't crash. It prints our helpful error message, and, this is the most important part, it keeps on going. Our application just survived what would have been a fatal error.
Catching errors is great. It really is. But what about those things that absolutely positively have to happen, error or not? I'm talking about closing a file you've opened or releasing a database connection. You can't just leave those hanging. For that, you need a cleanup crew. And in Java, that crew is called the finally block.
Here's the amazing thing about finally. It's a rock-solid guarantee. It doesn't care if your try block finished perfectly. It doesn't care if an error was thrown or caught. Either way, the code you put inside the finally block is always going to run. It gets the last word no matter what. That's what makes it absolutely perfect for that critical cleanup. Now, this is how we used to have to do it. This is the old way. And just look at how much code that is. You have to declare your file stream outside the try block. Then way down in the finally block, you have to remember to check if it was even created before you try to close it. It works, sure, but it's clunky, it's ugly, and it's a super common place to introduce bugs.
Now, take a look at the modern way. This is a game changer. It's called the try with resources statement. See how we declare the file stream right inside the parentheses after try? By doing that, you're telling Java, hey, you manage this for me. And it does. The file stream is automatically and guaranteed to be closed when the block is done. No finally block needed. It's just cleaner, shorter, and a whole lot safer.
The benefits here are just huge.
I mean, first off, you're getting rid of all that extra boilerplate code, which makes everything way easier to read. But more importantly, you're preventing one of the most classic and sneaky bugs in Java, resource leaks. Seriously, this isn't just a style preference. Try with resources is the modern standard for a very good reason.
Okay, so this is a really important idea to get your head around. Not all exceptions are the same. If you really want to master this stuff, you have to go from just reacting to errors to actually anticipating them, and that all starts with understanding the two main kinds of exceptions in Java.
It really all comes down to one thing: intent. Checked exceptions are for problems that you can reasonably expect might happen, and that you can probably recover from. Think about trying to read a file. It might not be there. That's an I/O exception, and the compiler forces you to handle it. On the other hand, you have unchecked exceptions. These are almost always just programming mistakes, bugs, like a null pointer exception. The compiler doesn't make you catch these because the right move isn't to catch the error, it's to go back and fix the bug in your code that caused it in the first place.
Whew. Okay, we have covered a lot of ground here, right? We've gone from the chaos of a program crash all the way to writing controlled professional code. So let's do a quick recap of the powerful tools we've just added to your developer toolkit.
So here's what you really need to remember. Exceptions happen, they disrupt the flow, but handling them is what makes your code strong. Try-catch is your fundamental safety net. Your cleanup crew is the try with resources block. Use it. And maybe the most important takeaway, you need to handle the problems you can anticipate. Those are checked exceptions. But for unchecked exceptions, your job is to go fix the bug.
By really getting a handle on these concepts, you've totally flipped the script. You've gone from being a victim of errors to being the one in control. You now have the tools to make your apps more resilient, way more user-friendly, and just flat out more professional. So the only question left is, now that you have this power, what are you going to build?